ado, I'm going to move on to our next speaker, Jack Zhu, who is the founder and managing director of Agescan International. They are a leading specialty company in Canada, renowned for their premium tungsten parts and products tailored for nuclear energy, nuclear medicine, radioisotope, and diagnostic imaging sectors. Over to you, Jack. Thank you.
Thanks, Andrew, for the introduction. Good morning, everyone. Thank you for taking time with us today. So today I'm going to present you a magical metal material is called tungsten and how its application in the nuclear sector. So here are the four main points of content I will share with you. What is a tungsten and the tungsten alloy and the tungsten properties of tungsten? And the third is how tungsten can help in the nuclear isotope industry. And finally, we can compare tungsten and its main competitor, lead, the metal lead, the pros and cons. So first is that tungsten is a metal originally found in 1781. And the name is derived from a Swedish term meaning heavy stone. It has been assigned the chemical symbol W after its German name Wolfram, and the atomic number is 74. It has grayish white and a lustrous look. It is a rare metal on Earth, and as we know, and China currently has the most global reserve and produces 85% of global tungsten output. Tungsten have two major types of finished product in the market, which are tungsten carbide and the tungsten alloy. So which we're talking about today is a tungsten alloy. Tungsten alloy has a two common composition, which is a tungsten nickel and iron, and a tungsten nickel and a copper composition. The latter one is with a non-magnetic. So tungsten parts usually use a pressing metal injection molding, which we call MIM, and 3D printing for forming process. Thanks to the tungsten's excellent machinability, we can use various CNC machining process to produce a complex structured parts on pressed tungsten blank. In addition, tungsten has incredible high absorption capacity for radiation due to its high density. So this is the slide shows the property of a tungsten. First is a physical property. They have the highest melting point at a 3,422 Celsius degree. Pure tungsten has a density of 19.35 grams cc. Compared to tungsten alloy, take a class 4, for example, they have about 18.5 grams cc, only second to gold. And it also has an extreme hardness, second to diamond. It has an average about 35,000 to 38,000 megapascal modulus, which shows it's a strong resistance to being deformed elastically. In the chemical side, tungsten is a long-reactive metal and very much anti-corrosion. So tungsten, how we can help in the nuclear isotope industry. Let's look at the industry itself. So based on a statistic from a World Nuclear Association, over 50 million nuclear medical procedures worldwide are performed each year. Among them, 40 million using isotopes, with 30 million for diagnostic and 4 million for radiation therapy. In addition, sterilization of medical equipment is also an important use of isotopes. The demand for isotope in three major applications is steadily growing. Canada has been a consistent leader in producing radioisotope for medical use in the global stage. One of the examples is a cobalt-60, the most common isotope used in radiation therapy. Canada produces 70% of global supply and refines 90% of global market demand currently. Thus, we can see the Canadian market provides enormous opportunities for tungsten. The absorption behavior of tungsten alloy for high energy electromagnetic radiation is derived from the high linear absorption coefficient of a principal tungsten phase. These alloy are excellent material for the shielding and collimation of X and gamma radiations due to their combination of its radiographic density, machinability, and its strength and low toxicity. Tungsten, it can offer a superior protection level to lead in an equivalent thickness. Like Steve company's Miron, they have a well-known product called ProTech path switching shielding. With only 0.34 inch thick tungsten, it can attenuate FDG-F 18 by 88%. The picture on this slide, the white container you can see is a FDG container, valve container. It's about a 5-inch high and a 3.6-inch external diameter, and it weighs 31 pounds. So its tungsten is very heavy. It is a great tool for store and transport radioisotope. So we can say tungsten is also a great material for radioactive and PET waste bin containers. In the box shielding application, tungsten products have been manufacturing many shielding components in the 100 to 1,000 kilo size range. Large isotope container can be fabricated with a complex geometry radio beam ports using radiation joint construction. In that case, ASTM B777, like a class 2, 3, 4, are typically used in this shielding. And take another example. So tungsten can use for target interference skit. And also in that isotope production system, you can use it for decay zone and the Q zone shielding area. So lastly, let's look at two metals comparison. So tungsten versus lead. First and foremost is their density. Tungsten is 70% denser than lead, average at 18 grams cc versus lead is at 11 grams cc. When we use both materials with the same thickness in the shielding scenario, so tungsten has a much better efficiency. Thirdly, we can see that tungsten generally has a smaller profile versus lead usually is larger and needs stainless steel to wrap. Next, we can move to see that tungsten is non-toxic versus lead is toxic. And in terms of its hardness, tungsten lead is about 1.5 in Mohs value versus tungsten is a 7.5. It's 5 times like a hard. Normally, tungsten alloy have a HRC value at 28 to 32 HRC. And tungsten can be tapped, can be drilled, can be phased to have a complex structure, as we earlier discussed. On the other side, lead has a softer nature, and the pressure from the fixture and the cutting tools on lead-based parts can cause the product to be out of specs. And lastly, tungsten can resist extreme high temperature, but lead cannot. The only disadvantage for tungsten is very costly. It's about 20 times of lead for raw materials. So this is my last slide. So this concludes our slide. We are here. Agescan is a 20 years experience in the specialty material industry. We can here help your tungsten, the radiation shielding needs. Thank you.
Excellent. Thanks so much.